Part 1. Doctor stood in the observation gallery of the Grand Assembly Hall, his four eyes focused on the data streaming across the holographic display. The numbers made no sense. Every pedagogical theory the Galactic Educational Consortium had developed over the past 3,000 years. Humans were publishing breakthrough research at a rate that shouldn't be possible. Their scientists, most barely 200 years into their careers, were solving problems that had stumped the galaxy's finest minds for generations. Even more disturbing, their students, actual students still in training, were routinely making discoveries that earned them respect from researchers 10 times their age. The researcher tapped his claws against the railing, a nervous habit from his youth. Around him, representatives from 40 different species murmured in confusion, and if he was honest, growing concern. Humanity had only joined galactic society 70 years ago. By all reasonable measures, they should still be learning the basics. "It must be genetic modification," announced Director, whose silver skin gleamed under the hall's lights. "There is no other explanation. They have enhanced their cognitive abilities beyond natural limits." "We tested for that," replied, his voice carrying the harmonic undertones of his species. "Multiple times. Human genetics are entirely natural. No enhancements, no modifications, nothing that would explain this." "Then they're hiding something," insisted. "Some technology perhaps, a neural interface that accelerates learning." Had considered that possibility. He had considered every possibility. None of them fit the evidence. The humans weren't cheating, at least not in any way the consortium could detect. They were simply producing scientists at a quality and quantity that broke every model of educational development the galaxy had ever created. That was when the consortium gave him an assignment. Go to Earth, observe their educational system directly, find out what made humans so remarkably good at science. 3 weeks later, materialized in the transportation hub of a city called Boulder, Colorado. His human liaison, a cheerful woman named Dr. Sarah, greeted him with a warm smile that showed her teeth. He had learned this was a friendly gesture among humans, though it still triggered ancient predator awareness instincts in his brain. "Welcome to Earth, Doctor," Sarah said, extending her hand. He grasped it gently, still unused to the human custom of physical greeting. "I've arranged for you to visit several educational institutions. Elementary schools, middle schools, high schools, and universities. You'll get the full picture of how we teach science." "I appreciate your cooperation," said, adjusting the translator device on his collar. "The consortium is very interested in understanding your methods." Sarah's smile widened. "I think you're in for some surprises." She had no idea how right she was. The next morning found himself standing in a classroom full of human children. They were young, perhaps 7 or 8 years old by human reckoning. The room was chaos, absolute chaos. Children moved freely between tables covered with various materials. Some were mixing liquids in transparent containers. Others were building structures from wooden blocks. One group was taking apart an old mechanical clock, pieces scattered across their workspace. In any proper galactic educational facility, students sat in neat rows. They listened to the instructor. They memorized the information presented. They did not touch anything without explicit permission. They certainly did not dismantle equipment. The human teacher, a middle-aged man named Mr., noticed discomfort. First time observing a human classroom. "Yes," admitted. "Is it always so unstructured?" Mr. laughed. "This is actually pretty calm. Wait until we get to the experiment phase." As if on cue, a girl with dark braids raised her hand. "Mister, can we test if the vinegar reaction works with different types of containers?" "Good question, Maya. What's your hypothesis?" "I think plastic containers will work better than glass because they're lighter and won't break." "Interesting. How will you test that?" The girl thought for a moment. "We could do the same reaction in both types and see what happens." "Sounds like a plan. Be careful and record your observations." Watched in growing alarm as Maya and her partner gathered materials. In a school, a student would never be allowed to design their own experiment. They would follow established procedures, proven methods, tested protocols. The idea of letting a child make up an experiment seemed incredibly dangerous. And yet, as he watched, something remarkable happened. Maya's hypothesis was wrong. The container type made no difference to the chemical reaction, but instead of being discouraged, she grew more excited. She started asking new questions. Why didn't it matter? What did matter? Could they test the temperature instead? Mr. didn't give her the answers. He asked more questions. He guided her thinking without telling her what to think. And Maya, faced with her failed hypothesis, didn't shut down or feel ashamed. She got curious. "You let them be wrong," said quietly. "We encourage them to be wrong," Mr. corrected. "Being wrong means you learned something. Every failed experiment teaches you what doesn't work, which gets you closer to what does." This was completely backwards from galactic educational philosophy. Students were taught to avoid errors at all costs. Mistakes meant failure. Failure meant shame. The entire system was built around getting the right answer the first time. Over the next hour, observed something that shook his understanding of education. A boy's tower of blocks collapsed, and instead of being upset, he excitedly told his teacher that now he knew which designs were unstable. A pair of students argued about whether plants needed light to grow, and the teacher suggested they set up an experiment to find out rather than simply telling them the answer. Another group's chemical mixture fizzed over the side of their container, and the teacher's first response was to ask them what they thought had gone wrong. The classroom was noisy, messy, and utterly unlike anything in galactic education. It was also alive with genuine curiosity and learning. That afternoon, visited a high school. Teenage humans, gangly and energetic, filled a laboratory where they were conducting an experiment on electromagnetic induction. But the experiment wasn't from a textbook. It was student-designed. A girl named Jennifer explained her project. "We're trying to build a more efficient generator using different core materials. Most of what we've tried hasn't worked, but we think we're getting closer." "Your instructor allows you to pursue a project that might not succeed?" asked. Jennifer looked confused by the question. "That's kind of the point. If we already knew the answer, it wouldn't be research." Research. These were high school students, and they thought of themselves as doing research. In galactic society, research was reserved for senior scientists with decades of training. Students learned what was already known. They didn't investigate the unknown. Later, he sat in on a university lecture about quantum mechanics. He expected this, at least, would follow familiar patterns. Surely, at the university level, humans adopted proper academic protocols. The professor, an elderly man with wild white hair, wrote an equation on the board. Then he turned to his students and said, "I think this approach is wrong. Can anyone tell me why?" Nearly fell out of his seat. A professor admitting potential error, asking students to correct him. This was unthinkable. In academia, professors were authorities. Their word was not questioned, especially not by students. But the human students didn't seem surprised. Several raised their hands. A young man stood and walked to the board, pointing out an assumption in the equation that didn't hold under certain conditions. The professor nodded, thanked him, and revised the equation. "Good catch. This is why we work through problems together. I make mistakes all the time." After the lecture, spoke with the professor. "You intentionally present errors to your students." "Sometimes," the professor admitted. "But that wasn't intentional. I actually made a mistake. It happens. The point is to create an environment where finding and correcting errors is normal. Science doesn't progress through perfect understanding. It progresses through being wrong, recognizing it, and getting less wrong over time." That evening, sat in his temporary quarters, reviewing his notes. Everything he had observed contradicted established educational theory. Human children were encouraged to break things, to experiment freely, to fail without shame. Human students argued with their teachers. Human teachers admitted mistakes. The entire system seemed built on the acceptance, even celebration, of being wrong. And yet it produced brilliant scientists. The data didn't lie. Human researchers were making breakthroughs that surpassed species with far older academic traditions. There was one more thing had noticed throughout the day. Human students at every level asked the same question constantly. Why? Why does this work? Why doesn't that work? Why do we think this is true? Why should I believe you? In education, students learned what was true. The why was less important than the what, but humans seemed obsessed with understanding the reasons behind everything. They didn't just memorize facts, they interrogated them. The next day, he visited an elementary school science fair. Young humans stood by displays showing their projects. One caught his attention immediately. A boy, perhaps 9 years old, had built a model volcano, standard enough. But something had gone wrong. The eruption mechanism had malfunctioned, spraying vinegar and baking soda across 3 neighboring displays. Waited for the punishment. In a school, such a failure would result in reprimands and possibly academic penalties. The boy would be taught that mistakes of this magnitude were unacceptable. Instead, the boy's teacher knelt beside him. That was exciting. What do you think went wrong? The boy, who had been close to tears, paused. I think I used too much vinegar. Good hypothesis. What else might have contributed? Maybe the tube was too narrow. Could be. How could you test that? I could try different tube sizes with the same amount of vinegar. Excellent. Want to try that now? We can clean up first, then experiment. The boy's face transformed from upset to excited. Within minutes, he was testing variables, trying to figure out why his volcano had become a geyser. The teacher helped him document his findings. By the end, the boy had learned more from his spectacular failure than he would have from a perfect success. Recorded everything with growing unease. This wasn't just a different educational approach. This was a completely different philosophy about what learning meant. Humans didn't teach their children to avoid mistakes. They taught them to learn from mistakes. They didn't punish failure. They used it as a tool. As he returned to his quarters that night, one thought dominated his mind. Human science education worked because it mirrored the scientific method itself. Question everything. Test your ideas. Accept that you'll be wrong. Learn from being wrong. Try again. Humans weren't just teaching science. They were teaching their children to think like scientists from the very beginning. And that changed everything. Part 2. The preliminary report that's submitted to the Galactic Educational Consortium caused an immediate uproar. 3 senior directors demanded his recall, claiming he had been compromised by human propaganda. 5 others insisted his findings required immediate further investigation. The debate raged for 2 full cycles before reaching a compromise. The consortium would establish a pilot program. Human educational methods would be tested in a controlled environment with willing participants from multiple species. If was right, if human methods truly were superior, the data would prove it. If he was wrong, the entire matter could be dismissed as an anthropological curiosity. 6 months later, Station 7 opened its doors to a very unusual group of students. 20 young researchers, recently graduated from their species' most prestigious institutions, arrived to participate in what the consortium was calling the Experimental Pedagogical Initiative. They came from 12 different species, each convinced they would prove that their traditional education was perfectly adequate. Watch them arrive with a mixture of hope and dread. The human education consultants, led by Dr. Sarah and joined by 2 other specialists, had spent weeks preparing the facility. They had argued constantly with the consortium about seemingly minor details. The humans insisted on movable furniture, open laboratory access, and what they called collaboration spaces. The consortium's architects found all of this highly irregular. The first session began with introductions. The students sat in a circle, another human innovation that the consortium found uncomfortably informal. Sarah stood in the center, her warm smile radiating confidence. Welcome, everyone. Over the next 6 months, we're going to explore science together, not the way you were taught before, but in a new way. Some of it will feel strange. Some of it might feel wrong. I promise you it will be interesting. A named raised his hand with military precision. His species valued hierarchy and academic honor above all else. Instructor, what will our individual rankings be? How will excellence be measured? Sarah's smile didn't waver. We won't have rankings. You'll be assessed on your growth, your curiosity, and your contributions to the group's learning. The room erupted in confused chittering and whistles. A researcher spoke up. Without rankings, how do we know who is performing best? That's not really the point, Sarah replied. We're not competing against each other. We're working together to understand the universe better. Your success doesn't depend on someone else's failure. Could see the concept wasn't landing. These researchers had spent their entire lives in systems where academic standing was everything. The idea of learning without competition was almost incomprehensible. The first week was a disaster. The human instructors introduced open-ended problems, questions without single correct answers. They expected students to explore possibilities, to try approaches that might not work, to discuss their thinking with peers. Instead, the students sat in uncomfortable silence, waiting to be told what to do. When forced to work in groups, old patterns emerged immediately. Refused to collaborate, insisting that his work would be contaminated by association with researchers from less rigorous academic traditions. A named wouldn't speak during discussions, too anxious about saying something incorrect. The students tried to establish a hierarchy within their group, wasting hours debating who should lead. Watch from the observation deck as Sarah and her colleagues struggled to maintain their optimism. The human approach required students to take intellectual risks, to be vulnerable in front of their peers, to admit uncertainty. These researchers had been trained since childhood to project confidence and avoid any appearance of weakness. Then came the breaking point. A young named was working on a problem involving exotic particle interactions. She had developed a hypothesis, designed an experiment, and spent 3 days collecting data. When she analyzed the results, they contradicted her hypothesis completely. She sat at her workstation, staring at the numbers, her skin fatting to a pale gray that indicated distress. Sarah noticed and approached. You okay? My hypothesis was wrong, said, her voice barely audible. I failed. You didn't fail, you learned something. I learned that I'm not good enough to be here. Sarah pulled up a chair. Can I tell you about my research? Looked up, confused by the change in topic. I spent 2 years developing a theory about quantum cascade reactions. 2 full years. I designed experiments, ran simulations, wrote papers. My advisor thought it was brilliant. I thought I was going to revolutionize the field. Sarah paused, smiling at the memory. My hypothesis was completely wrong. The data contradicted everything I'd predicted. What happened? I had a good cry, ate a lot of ice cream, and then got curious about why I was wrong. It turned out the actual mechanism was way more interesting than what I'd proposed. That wrong hypothesis led me to a discovery that became the foundation of my career. Sarah leaned forward. Being wrong isn't failure. Being wrong and learning nothing is failure. You just discovered something real about how the universe works. That's science. Skin color began to shift back toward normal. My professors would have been disappointed. Then your professors never really understood science. That conversation marked a turning point. Didn't hide her failed hypothesis. Instead, during the next group session, she presented it openly, explaining what she had learned from being wrong. The human instructors praised her. They called it brave. They said it demonstrated real scientific thinking. The other students watched in amazement, as received positive recognition for admitting error. Slowly, cautiously, things began to change. The quiet started speaking up more. The humans had introduced something called stupid question time, where students could ask anything without judgment. Discovered that her stupid questions often led to the most interesting discussions. Her perspective, coming from a species with very different sensory biology, helped others think about problems in new ways. Took longer to adapt. He resisted group work, insisting on individual achievement. Then one day, struggling with a complex mathematical proof, he mentioned his difficulty to a student named Thane. Thane suggested a different approach, one would never have considered. Together, they solved the problem in an afternoon. Was forced to admit that collaboration had value, though he did so grudgingly. The human instructors introduced more unconventional methods. They had students teach each other, claiming that teaching was the best way to learn. They encouraged playing around with equipment, just seeing what happened. They praised creative failures more than routine successes. They held sessions where students had to defend ideas they didn't believe in, forcing them to see multiple perspectives. Most radically, they introduced office hours. Students could meet with instructors one-on-one and ask anything. The power dynamic that defined galactic education, where professors were unquestionable authorities, simply didn't exist. Sarah and her colleagues treated students as junior colleagues, not subordinates. 3 months into the program, a breakthrough occurred. A mixed species team consisting of and a tertian researcher named Block were working on a problem involving exotic matter containment. They had approached it from 3 completely different theoretical frameworks. In a traditional galactic institution, each would have worked separately within their species' established methodology. Instead, during a late-night session fueled by what humans called coffee, they started combining approaches. Particle physics background, unique sensory understanding of field dynamics, and Bloch's mathematical elegance merged into something new. By morning, they had developed a containment method that improved efficiency by 40%. More importantly, it was a solution that could only have emerged from genuine collaboration, from researchers willing to share incomplete ideas and build on each other's thinking. When they presented their findings to the full group, the room fell silent. This wasn't incremental improvement. This was innovation. This was the kind of breakthrough that happened once in a generation. Sarah looked at in the observation gallery. He could see the question in her eyes. Are they getting it? He nodded slowly. They were beginning to understand. The next breakthrough came from an unexpected source, who had resisted human methods most strongly, published a paper that questioned a fundamental assumption in physics, his own species physics. The assumption had stood for 500 years. Applying human-style critical thinking, identified a flaw in the original reasoning. His paper caused a scandal on Prime. Several senior academics called for his censure. How dare a junior researcher question established theory, but stood firm. He had learned from the humans that questioning assumptions wasn't disrespectful, it was essential. When his analysis proved correct, when experiments confirmed that the 500-year-old assumption was indeed flawed, the entire galactic scientific community took notice. A student from the experimental program had overturned established dogma not through advanced equipment or genetic advantages, but through a different way of thinking. Applications to join the next cohort of the program flooded in. Not everyone in the program succeeded. A student named couldn't adapt. The anxiety of not knowing the right answer, the stress of constant experimentation, proved too much. He, after 4 months, requesting return to traditional education. The human instructors didn't judge him for it. They acknowledged that learning styles differed, that what worked for some might not work for all. But for those who stayed, the transformation was remarkable. watched researchers who had arrived as rigid, hierarchy-obsessed specialists become curious, collaborative scientists. They learned to say, "I don't know, let's find out." They learned to value questions as much as answers. They learned that being wrong was temporary, but refusing to try was permanent. The final project required teams to tackle an unsolved problem in their field. Not a textbook exercise, but real research. The humans provided guidance but no solutions. Students had to figure out what questions to ask, what methods to try, how to work together effectively. The results exceeded Evan's optimistic projections. 5 teams produced publishable research. 2 made discoveries significant enough to warrant immediate follow-up studies. 1 team, attempting to solve one problem, failed completely but accidentally stumbled onto something more interesting, which they pursued instead. That last one made the human instructors particularly proud. The students had learned to recognize when failure opened new doors. As the program concluded, prepared his final assessment. The data was undeniable. Students taught with human methods showed increased creativity, better collaborative skills, higher rates of novel problem-solving, and most importantly, a fundamentally different relationship with the scientific process itself. They had learned to think like scientists, not just memorize science, but knew that presenting these findings to the consortium would be the easy part. The hard part would be convincing galactic civilization to abandon thousands of years of educational tradition, to admit that humans, the newcomers, had figured out something fundamental that everyone else had missed. He looked out at the 7 students celebrating their final presentations, species mingling freely, sharing ideas with enthusiasm and warmth. This was what education could be. The question was whether the galaxy was ready for it. Part 3. The Grand Assembly Hall of the Galactic Educational Consortium had never been so crowded. Representatives from 73 species packed the chamber, with thousands more watching via holographic feed. Stood at the central podium, 4 crystalline data cores containing his complete findings floating beside him. For 3 hours, he presented the results of the 7 pilot program. He showed the initial failures, the gradual transformations, the breakthrough discoveries. He displayed comparison data between traditionally educated researchers and those who had human-style training. The numbers told an undeniable story. When he finished, silence filled the chamber. Then the questions began. Director was first. "Doctor, your data shows improved outcomes in controlled settings, but how do we know this approach will work at scale, with younger students, across different species?" "We don't," admitted. "Not with certainty, that's precisely the point. Human education embraces uncertainty. They test, they learn, they adjust. I recommend we do the same." A elder, scales gleaming silver with age, stood next. "This approach undermines academic authority. It teaches students to question their instructors. How can we maintain educational standards when everyone is encouraged to challenge established knowledge?" Sarah, watching from the guest section, raised her hand. The presiding director, surprised that a human would interject, nevertheless granted her permission to speak. "With respect," Sarah said, her voice calm but firm, "that's not undermining authority. That's understanding what authority actually means. Scientific authority comes from evidence and reasoning, not position. If a student can challenge an idea with better evidence, that student should be heard. That's how science advances." The murmur that followed was mixed, some agreeing, some clearly affronted. The debate continued for days. Conservative factions argued that human methods were dangerous, promoting chaos and disrespect. They pointed out that galactic civilization had functioned for under traditional education. Why change what worked? Progressive factions countered that working was generous. When was the last major scientific revolution? When had galactic science truly leapt forward rather than incrementally refined existing knowledge? The Terrans had been spacefaring for barely a century, and were already publishing breakthrough research. That wasn't chance. That was their educational system bearing fruit. Watched the debate with growing frustration. The evidence was clear. The data was overwhelming. Yet fear of change, attachment to tradition, and simple pride kept many from accepting what should have been obvious. Then something unexpected happened. 3 species, independently, announced they were implementing human-inspired reforms in their educational systems. The Tertians, and surprisingly, a faction of progressives. They didn't wait for consortium approval. They simply began changing how they taught their children. Within a year, preliminary results started coming in. Tertian students showed increased engagement and creativity. Youngsters, traditionally shy and reluctant to speak up, began asking more questions. The reform schools reported students solving problems in novel ways, combining ideas from different disciplines. The results weren't perfect. There were challenges. Some teachers struggled with the less structured approach. Some students found the change stressful, but the trend was undeniable. Human-style education was producing more engaged, more creative, more scientifically minded learners. Other species began to pay attention. Meanwhile, humanity itself watched the galactic debate with bemusement. To them, their educational approach was just common sense. You let kids explore, make mistakes, ask questions. You encouraged curiosity. You treated failure as data. None of this seemed revolutionary to humans. It was simply how learning worked. Doctor gave an interview to a galactic news network that went viral across multiple species information networks. The interviewer, a journalist, asked why humans had developed such unusual educational methods. "I don't think we set out to be unusual," Sarah replied. "We just noticed that kids learn best when they're actually interested in what they're learning, and they get interested when they can touch things, break things, figure things out themselves. We're not smarter than other species. We just structured our education around how learning actually happens instead of how we wished it happened." That interview sparked something. It reframed the debate from "should we adopt human methods" to "why haven't we been teaching like this already?" The human approach wasn't some exotic innovation. It was just effective teaching. A breakthrough came from an unexpected source. The Academic Council, one of the most conservative institutions in the galaxy, published a study. They had quietly been running their own experiments, comparing students in traditional versus reformed programs. The reformed students, taught with human-inspired methods, outperformed their traditionally educated peers in every meaningful metric. The council's conclusion was carefully worded but clear. Educational reform is necessary to maintain academic excellence in an increasingly competitive galactic environment. In other words, adapt or fall behind. That publication shifted the momentum. If even though we're reforming, resistance elsewhere began to crumble. The consortium voted to establish comprehensive reform guidelines. They weren't mandatory. Each species could choose their own path, but the recommendations were heavily influenced by human pedagogical philosophy. Found himself in constant demand as a consultant. Species wanted to know how to implement these changes. What worked? What didn't? How did you train teachers who had themselves been educated traditionally? How did you convince parents that letting their children fail was actually good? He worked with Sarah and her team to develop training programs for educators. They emphasized that reform wasn't about copying humanity exactly. Each species needed to adapt the core principles to their own biology, culture, and learning styles. Though, for instance, incorporated group sensory experiences that wouldn't work for species without their unique perception. The maintained more structure but introduced collaborative projects and question-based learning. The key wasn't the specific techniques, it was the underlying philosophy. Education should nurture curiosity. Failure should be a learning tool, not a punishment. Questions mattered as much as answers. Collaboration enhanced rather than diminished individual achievement. Scientific thinking could be taught from the earliest ages. 5 years after initial visit to Earth, the changes were visible across galactic civilization. Science fairs became common, with young researchers presenting projects that would have been considered too ambitious a decade earlier. Collaborative research teams mixing species became the norm rather than the exception. Academic journals saw an influx of papers challenging established assumptions, many from younger researchers who had been taught that questioning was expected. Not everyone was happy. Some species maintained traditional systems, arguing that their approach was culturally important. Some institutions resisted change, creating a divide between reform and traditional schools. Some parents worried that the new methods were too chaotic, too uncertain, not rigorous enough. But the data kept accumulating. Reformed education produced better scientists, not just more scientists, but better ones. Researchers who could think creatively, work collaboratively, and push boundaries. The kind of scientists who made real breakthroughs. Humanity's position in galactic civilization shifted subtly. They were no longer just the newcomers with surprising scientific output. They were educational pioneers, species whose insight into learning had helped revolutionize how the galaxy approached knowledge. Human educators found themselves teaching across the galaxy, helping implement reforms, training teachers, consulting on curriculum design. Some humans found the attention overwhelming. Others pointed out the irony. "We just let kids do science experiments in elementary school," one teacher told a documentary filmmaker. "We didn't think we were doing anything special. We certainly didn't expect to change galactic education." But that was precisely why it worked. Humans hadn't been trying to develop a revolutionary system. They had simply paid attention to how children actually learned and structured education around that reality. 10 years after the initial controversy, the Galactic Educational Consortium held a celebration. The pilot program at 7 had expanded into a full university, accepting students from across the galaxy. The curriculum blended human pedagogical philosophy with the best insights from dozens of species. It had become the most prestigious scientific institution in the galaxy, not because of its facilities or faculty, though both were excellent, but because of how it taught students to think. Attended the celebration as a guest of honor. He watched students from 20 different species working together in laboratories, arguing good-naturedly about experimental design, celebrating both successes and interesting failures. It was everything the pilot program had promised, scaled up and refined. Sarah found him watching from a balcony. "Thinking about that first day you visited an Earth elementary school." "Every day," admitted. "I was so certain you were doing everything wrong. Children running around, breaking things, asking endless questions. It seemed like chaos." "It was chaos," Sarah agreed. "But it was productive chaos. That's the part people miss. Structure is good, but too much structure kills curiosity. Learning needs space to breathe." "We spent thousands of years perfecting educational systems that taught students what to think," said quietly. "Humans taught them how to think. That's the difference." Below them, a group of students erupted in celebration. Their experiment had failed spectacularly, covering half the lab in foam, but they had learned something about reaction rates that contradicted their textbook. They were already designing a follow-up experiment, excited by the discovery their failure had produced. Sarah smiled. "Look at them. 5 years ago, that failure would have been devastating. Now it's just another day in the lab." "The galaxy owes humanity a debt," said. "You showed us what we had forgotten. That learning is exploration, not memorization. That being wrong is the path to being right. That science is a way of thinking, not just a body of knowledge." "We didn't do it alone," Sarah replied. "The species who had the courage to try something different, who trusted the data over their traditions, they deserve credit too. Change is hard. Admitting you've been doing something wrong is even harder." They stood in comfortable silence, watching the next generation of galactic scientists learn and grow and question and discover. The revolution wasn't over. Many systems still clung to traditional methods. Many educators struggled with the reformed approach. Change was messy and slow and sometimes frustrating. But it was happening. And every year, more students learned to approach the universe with curiosity rather than certainty, with questions rather than just answers, with the understanding that being wrong was temporary, but refusing to try was permanent. Thought back to that classroom in Boulder, Colorado, where a child's volcano had erupted incorrectly, and the teacher had helped him learn from it. That moment had changed the galaxy, not because it was a brilliant innovation, but because it was such obvious, simple wisdom that everyone else had somehow missed. Humans had built a civilization on the principle that being wrong was the first step toward being right. And now, slowly but surely, the rest of the galaxy was learning the same lesson. A young student approached them, scales shimmering with nervous energy. "Doctor, I had a question about your original study. You concluded that human methods work because they mirror the scientific method, but I was wondering if it's deeper than that. What if humans teach science well because they approach uncertainty differently, not just in education but culturally?" Felt a surge of joy. A perfect question, not accepting the conclusion but pushing deeper, looking for underlying principles. This student had learned to think like a scientist. "Excellent question," he said. "How would you test that hypothesis?" The student's scales brightened further. "Well, I was thinking we could look at human cultural artifacts, their fiction and art, see if themes of exploration and uncertainty appear more frequently than in other species' cultures. Then compare that to educational outcomes across multiple species to see if there's a correlation." Interesting approach. What would you need to control for? As the student launched into discussing confounding variables and experimental design, Sarah caught eye and winked. This, right here, was the revolution. Not policy changes or institutional reform, though those mattered. The real revolution was in moments like this, when a student learned to ask deeper questions, to challenge conclusions, to think like a scientist. The galaxy had finally learned what humans had known all along. You didn't teach people to be scientists by making them memorize facts. You taught them by helping them think scientifically from the very beginning. And once you learned to think that way, you never stopped questioning, exploring, and discovering. That was the gift humanity had given the galaxy. Not just better educational methods, but a fundamental shift in how entire civilizations approached knowledge itself. Looked out at the students below, from dozens of worlds, all learning together, all questioning together, all becoming better scientists together. The future of galactic science had never looked brighter.